Hello, thank you for watching. Having good water is kind of the precursor to doing chemistry, I found out. If you don't have good water, you're going to have shitty mineral deposits on your glass and a whole bunch of other problems. I went out and got a 5-stage reverse osmosis filter to try out. Process of doing that, I bought one of these cheap little TDS meters on Amazon. I think they're probably like under 15 bucks. So TDS just stands for total dissolved solids. It's a compilation of basically everything that's in the water, whether it would be good or bad. It could be minerals, salts, metals, charged ions, or anything kind of along that line. So we're going to check this TDS meter out here and see if it's a viable thing to basically give you an idea of where your water stands as far as quality goes. Now, it did come with some pretty good instructions. It says ideal drinking water from reverse osmosis, distillation, deionization, and microfiltration is 0 to 50 parts per million. So 1 part per million is actually 1 milligram of solid dissolved in 1 liter of water, just to kind of give you the perspective. That's a very, very small amount. Now, something that I do kind of question here, but you know, what do you want for 15 bucks? Is I think these are basically nothing more than what I would consider to be a glorified ohm meter, in that in order to determine the amount of solids, they just basically read the resistance of the water. Metals are certainly going to have the least amount of resistance, salts kind of ranking above them, and probably minerals. I think to kind of put that into perspective, when you stick this probe into the water to read the resistance, it's kind of like hanging an ohm meter across a bunch of series parallel resistors. The ohm meter shows you what the total resistance of everything is in the circuit, but it doesn't show you what the individual values are. And of course, if you want them, you got to use Ohm's law to compute them. So that's kind of analogous to how I believe that this TDS meter works. It basically reads everything in the water to form some type of overall value, if that makes any sense. So this is some water that I pulled off my new water filter. You stuff this in there and swirl it around. Technically, I don't know that you need to do that, but it's just, I'm still having flashbacks from my pH meter experience here. So it says 0 parts per million. This is some store-bought distilled here, if there's any in it. Might be enough there. I think we'll get it. 1 part per million. And it does kind of look like the probes are completely covered there. So 1 part per million in that. Now when you rinse this off in what I'm going to call the reference water, you will cross-contaminate it. But you know what? That's okay, because we only had 1 part per million to contaminate this with, so we're still going to read 0 parts per million. But as you start to get into a higher amount of solids dissolved in the water, you want to change out your rinse water every time, otherwise your cross-contamination will be too high. And that kind of goes the same way with switching back to the previous water container I used. So here's some dollar store drinking water with minerals. So we can probably guess that this is going to be higher. And it is. 21 parts per million. Here's some pretty weird water. 9.5 plus pH level, purified water with electrolytes. Not quite sure about the electrolyte thing there. Let's try some of this stuff. Okay, well obviously those electrolytes jacked the reading up there. We got 33 parts per million on that one. It's a little bit more of a dirtier water source, if it's even fair to say that. But it's still within the realms of drinking water type. Still under 50 parts per million. Let's try some well water now. So it pretty much goes red right away on the display. Reads 109 parts per million. My well water is monitored and said to be acceptable for drinking. Actually, strangely, that didn't cross-contaminate it because it's still reading 0. But we'll dump it out anyway. So back to what I was saying. 1 part per million is 1 milligram dissolved in 1 liter of water. Now, unfortunately, my cheap little scale here wouldn't do this with what I wanted to do. But I could get 100 milligrams out of this scale with no resolution, but I was able to get 100 milligrams out of it. So that kind of reinforces my thought on chemistry being a Trojan horse, because I need an analytical scale now because this scale just wouldn't do what I wanted it to do. But anyway, I made a solution which is sodium chloride and magnesium sulfate, just for the hell of it, just to see what would happen. So I dissolved 100 milligrams in 100 milliliters. If 1 milligram in 1 liter equals 1 part per million, then 100 milligrams in 100 milliliters of water should equal 1,000 parts per million. And I wanted a much smaller value, but like I said, my scale just kind of shit the bed on reading stuff that low. Let's just see what this reads. 1,485 parts per million. So, yeah, it's kind of close enough for horseshoes and hand grenades, maybe. I'd be curious to know if my scale, obviously my scale was off. If my scale would have been dead on, would this have read exactly 1,000 parts per million? Hell, who knows? It could have. So I'm just curious to see. There was so much stuff in there. That should have cross-contaminated this water. 1 part per million. Obviously my procedure of dumping the right beaker and cleaning it out enough is starting to work. But after you get a whole shit pile of beakers around you, you kind of lose your mind as to which beaker was what. But anyway, it works. So yeah, they don't say anything about these electrodes as far as maintenance to these. I mean, when you're working with pH meters and stuff like that have like bulb sensors and shit like that in them, every so often you gotta basically clean the contacts with like potassium hydroxide or something, at least as far as pH meters go. I can't imagine that this would be much different other than maybe what you'd clean it with. So I think that's kind of these contacts are kind of the weakness of this. If you don't keep them properly rinsed or cleaned in some amount of time, this thing's probably going to shit the bed and give you some erroneous readings. Man, it works. It's kind of a quick go, no-go type test, if I can use electronic words, as to how good your water quality is and how much junk is in it. So I think this thing was definitely worth the 13 or 15 bucks, whatever it was. You know, anyone that's starting chemistry or something like that, like myself, might be able to benefit from one of these. Apparently this says a temperature meter too. I'm not sure what the EC means on this just yet. But anyway, hey, I appreciate you watching my video today very much. Y'all take care and have a great day.